straight out of magazine. Caught on the nerves, but you never leave her.
Di kedalaman hutan cagar alam Pangandaran, terdapat sebuah dunia yang penuh dengan kehidupan dan kecerdasan yang luar biasa. Di sini, sebuah kelompok makhluk yang cerdas dan sosial menjalani kehidupan mereka dalam keteraturan yang menakjubkan. Mereka adalah makaka fascicularis, monyet ekor panjang yang memiliki kisah yang menarik di dalam hutan ini. Bergabunglah dengan kami dalam perjalanan ke dunia mereka yang penuh keunikan dan kehidupan yang meriah, di mana tiap gerakan, interaksi, dan perjuangan mengungkapkan keajaiban alam yang ada di sekitar kita. Perjalanan dimulai dengan menyusuri hutan cagar alam Pangandaran bagian luar. Di sini, kita dapat menemui beberapa kelompok makaka fascicularis, di antaranya kelompok Cikamal, kelompok Goa Jepang, kelompok Pasir Putih, dan kelompok Subpasir Putih. Keragaman dalam lokasi dan nama kelompok-kelompok ini mengungkapkan berbagai adaptasi dan kehidupan berkelompok yang berbeda-beda dalam spesies makaka fascicularis. Meski berbeda, terlihat serangkaian aktivitas yang mirip atau serupa di antara mereka. Aktivitas seperti grooming, berkejaran, berlarian, berkelahi, serta berinteraksi dengan manusia merupakan perilaku umum yang mungkin dijumpai di berbagai kelompok makaka fascicularis. Meskipun lingkungan dan kelompok berbeda, banyak perilaku yang tetap konsisten di antara makaka fascicularis, karena hal ini adalah bagian dari pola kehidupan alami mereka yang mendasar dan seringkali merupakan bagian penting dari kehidupan sosial dan adaptasi mereka terhadap lingkungan sekitar. Aktivitas lain yang terlihat dalam interaksi dengan manusia yang dipicu oleh kehadiran manusia di sekitar mereka. Adaptasi makaka fascicularis yang telah berinteraksi dengan manusia di cagar alam Pangandaran memperlihatkan perubahan yang signifikan dalam pola makanan mereka. Mereka yang biasanya bergantung pada sumber daya alam seperti
Morning Bu Mauli, terima kasih Bu.
Good morning.
Morning Dr. Simon Blom. Thank you for your coming to this opening session, as well as Professor Nazia Jamil. Thank you. Good morning. And good morning everyone and all participants in this conference.
Good morning.
Morning. Thank you, Prof.
Good morning.
Good morning, Prof. Can you hear my voice clearly? Okay.
Tikus ya.
Recording in progress.
Morning, Prof Harun. Terima kasih.
Selamat pagi Bapak Ibu dari Indonesia. Morning everybody.
Bisa kita mulai nggak, Prof?
Pagi.
Everyone, we are going to start this conference. And Master of Ceremony, please welcome.
Ladies and gentlemen, and I have a reputation is our session is about to begin. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning and welcome to the second International Conference on Biology, Education, Natural Science, and Technology. I am Ahmad Yani, your host for today. It's an honor to me to introduce and welcome the Advisory Council of Academic Research and Innovation. Universitas Muhammadiyah Surakarta. Profesor Dr. Representing the Union of Faculty and Teacher Relations and Representation, I.C. for Academic Affairs. Dr. Yani, Ph.D. On Incobest 2024, Dr. Yani,
Ph.D. Our invited speakers, Dr. Simon M. Blom, Ph.D. from Southern Cross University, Australia. Professor Dr. Nazia Jamil, Ph.D. Associate Professor, University of Punjab, Pakistan. And Dr. Vina Listiawati, Ph.D. from Universitas Muhammadiyah, Surakarta. Lecturers and staff of Biology Education Department, and all the participants of the conference. Alhamdulillahirabbil alamin. Thanks to Allah, the Lord of the universe, for his blessings and mercy for us to be gathered here in the second International Conference on Incobest 2024. May salawat and salam be shot down to our Prophet Muhammad sallallahu alaihi wasallam, who has guided us from the darkness of Jahiliyah to the brightness of Islam. Ladies and gentlemen, allow me to read the agenda for today. First is opening session. Second is singing the Indonesian national anthem and Sang Surya. Third is Al-Quran recitation and interpretation. Fourth is welcoming and opening remarks. Fifth is main event. Sixth is announcement. The last is closing session. Well, ladies and gents, we are now holding the first agenda. The opening by reciting Basmalah together. Bismillahirrahmanirrahim. The second agenda is singing Indonesian national anthem Indonesia Raya and Muhammadiyah official anthem Sang Surya. I would like to ask all participants to stand up as tribute to our national anthem. Thank you, ladies and gents. You may have your seat back. Our next agenda is Al-Quran recitation on Surah Al-Hajj, verse 63 until 66. Will be recited by Sister Halimah Tusadiah Taher and will be interpreted by Sister Nadifah Najwa. When the Quran is recited, listen to it attentively and be silent, so you may be shown mercy. We would like to ask all the participants to keep silence during the recitation.
Assalamualaikum warahmatullahi wabarakatuh. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. ألم تر أن الله أنزل من السماء ماء فتصبح الأرض مخضرة إن الله لطيف خبير. له ما في السماوات وما في الأرض وإن الله لهو الغني الحميد. ألم تر أن الله سخر لكم ما في الأرض والفلك تجري في البحر بأمره ويمسك السماء أن تقع على الأرض إلا بإذنه إن الله بالناس لرؤوف رحيم. وهو الذي أحياكم ثم يميتكم ثم يحييكم إن الإنسان لكفور. صدق الله العظيم.
I seek refuge with Allah from the temptation of the accursed devil. In the name of Allah, the most beneficent, the most merciful. Do you not see that Allah has sent down rain from the sky and the earth becomes green? Indeed, Allah is subtle and acquainted. To him belongs what is in the heavens and what is on the earth. And indeed, Allah is the free of need, the praiseworthy. Do you not see that Allah has subjected to you whatever is on the earth and the ships which run through the sea by his command? And he restrains the sky from falling upon the earth unless by his permission. Indeed, Allah to the people is kind and merciful, and He is the one who gave you life, and then He causes you to die, and will again give you life. Indeed, mankind is ungrateful. Allah Almighty speaks the truth. Wassalamualaikum warahmatullahi wabarakatuh.
Righteous God for all his words. Moving to the fourth agenda is welcoming and opening remarks. The welcoming remark will be delivered to you by the Dean of Faculty of Teacher Training and Education, Vice Dean for Academic Affairs, Dr. Mauli Halwat Hikmat, Ph.D. Please welcome Dr. Mauli Halwat Hikmat, Ph.D. Time is yours.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Alhamdulillahirabbil alamin wassalatu wassalamu ala asrofil anbiya'i wal mursalin wa ala alihi wa sahbihi ajmain amma ba'd. The Honorable Director of Universitas Muhammadiyah Surakarta, the Vice Rectors, the Dean of the Faculty of Teacher Training and Education of Universitas Muhammadiyah Surakarta, the keynote speakers, Dr. Simon M. Blom from Southern Cross University, Australia, Professor Nana Jamil from Universitas of Punjab, Pakistan. Good morning to you all. And Dr. Vina Listiawati from FKIP UMS. And the heads of English departments and all invited guests, presenters, participants, good morning to you all and welcome to our international conference Incobest. Thank you for gathering here today for the Incobest. It is my great pleasure on behalf of the Dean of Faculty of Teacher Training and Education, Professor Dr. Sutama, to extend a warm welcome to each of you. This conference marks a significant milestone in our ongoing pursuit of knowledge and excellence in the field of biology and natural science. We are honored to host such distinguished experts and passionate educators from all over the world. Here we have from Pakistan, from Australia, and also from what else? Indonesia, of course, who have lives to advancing our understanding of natural world and shaping the future of science education. In this conference, we will delve into critical issues, explore innovative research, share best practices that will undoubtedly inspire new collaboration and initiatives. The challenges we face in today's world demand nothing less than our collective expertise and commitment to fostering a deeper appreciation and understanding of biology and natural sciences among the next generation of scholars. I encourage you all to engage fully in the discussions, exchange ideas freely, and forge partnerships that will transcend borders and disciplines and contribute to a more sustainable and prosperous future for science education. Once again, welcome to Incobest, FKIP UMS, and thank you for your participation. Hopefully, this conference will become a memorable and impactful experience for all. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Ms. Dr. Mauli Halwat Hikmat, Ph.D., for the welcoming remarks. Next is the opening remark that will be delivered by Vice of Academic Research and Innovation of Universitas Muhammadiyah Surakarta, Profesor Dr. Harun Joko Prayitno, Magister Humaniora. Profesor Dr. Harun Joko Prayitno, Magister Humaniora, time is yours.
Oke, makasih Mbak. Jackson, kedengaran nggih?
Iya, Prof.
Oke, terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirabbil alamin. Wassalatu wassalamu ala Rasulillah wa ala alihi wa sahbihi wa mawalah. Asyhadu an la ilaha illallah wa la syarikalah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma sholli ala Muhammad wa ala ali Muhammad. Good morning everybody from Indonesia, from Solo, especially in Raja Indonesia. I have represented the Chancellor UMS, Professor Yani, because there are the activities today. Firstly, we thank to Allah Subhanahu wa Ta'ala together with Alhamdulillahirabbil alamin, which give us blessing and heavenly hidayah and inayah, so we can gather on this conference, and also to our greatest Prophet Rasulullah Muhammad SAW, who guided us to the right way. Ladies and gentlemen, once more again, good morning and welcome to the International Conference on Biology Education, Natural Science and Technology, or Incobest, hosted by Biology Education Universitas Muhammadiyah Surakarta, Central Java from Indonesia. I would like to extend my warmest greetings and heartfelt gratitude to all the distinguished esteemed speakers, researchers, educators, all of course students and participants who have gathered here from different corners, different countries, different area of the globe to part of this significant event. Today, we have the privilege of hosting esteemed speakers who have made remarkable contributions in their representative field. Special gratitude toward the keynote speakers. The one keynote speaker, Simon M. Blom, Ph.D. from Southern Cross University, Australia. Good morning from Indonesia. I'm very happy to meet you. Join to this conference from Universitas Muhammadiyah Surakarta. And then Professor Nazia Jamil, Ph.D. from the University of Punjab, Pakistan. Maybe often there early morning, yeah. Thank you so much. Have you joined to this conference? And finally, I want to thank to the new PhD, Dr. Vina Listiawati, PhD, prominent lecturers from biology education from Universitas Muhammadiyah Surakarta. Ladies and gentlemen, this conference with the theme of biological roles, the solve environmental issues, highlight the crucial role to support the environment and sustainability development. As we confront pressing challenges such as climate change, biodiversity loss, and environmental degradation, It is imperative that we unite as a global community to explore innovative solutions and embrace the principles of sustainable development. Ladies and gentlemen, UMS is a continuing status as a university in top level in Indonesia, in top level or unggul by Indonesian accreditation, BAN PT or LAM on the other accreditation international reputation. UMS demonstrated its commitment to sustainable development goals, earning global recognition in the impact ranking in 2024. Also, UMS has a mission to be an international recognized university or world-class university in 2029. So, by this event, we hope the relationship and cooperation between UMS, especially biology education, and our university partner could get mutual benefit both of us and always improve the research and publication impact and conference, of course, and for all. I am delighted to know that this conference has received an overwhelming response with a total of 46 more presented papers from across countries, such as Algeria. Good morning from Indonesia to presenter from Algeria, and then from Pakistan. Good morning from Solo, Indonesia, Central Java to presenter from Pakistan and Australia, and finally, as well as, of course, from Indonesia. These articles present cutting-edge research and innovative ideas in the field of natural science and education. It is encouraging to see such active participants from researchers, educators, students from different parts of the world. Finally, I would like to express my heartfelt appreciation to the organizing committee. Thank you so much to organizing committee, the scientific committee, and all the individuals who have worked tirelessly to ensure the success of this conference. Your dedication and hard work have brought us all together in this rising environment. Once more again, I extend my warmest welcome to all the participants, speakers, and guests. Thank you, and I wish you all a fruitful and memorable conference. Enjoy the conference. Will be, let's us together with Basmalah. Bismillahirrahmanirrahim. Thank you so much, everybody.
Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Professor Dr. Harun Joko Prayitno, Magister Humaniora, for officially open the conference. Ladies and gents, soon we'll join the main event. But before that, let's give some preparation time to our invited speakers by enjoying this video presented by Biology Education Department.
Terima kasih, Bro.
Studi Pendidikan Biologi Fakultas Keguruan dan Ilmu Pendidikan Universitas Muhammadiyah Surakarta adalah lembaga pengembang keilmuan pendidikan biologi berdasarkan nilai-nilai keislaman, memberi arah perubahan dan pengembangan ipteks yang islami dalam rangka mewujudkan lulusan berkualitas, kompetitif, dan memiliki jiwa wirausaha. Melalui pengalaman panjang sejak berdiri pada 1 November 1985, saat ini program studi pendidikan biologi Universitas Muhammadiyah Surakarta merupakan salah satu program studi yang bereputasi nasional dengan peringkat akreditasi unggul dari Badan Akreditasi Nasional Perguruan Tinggi pada tahun 2021. Terletak di kota Surakarta, sebuah kota yang memadukan keindahan budaya Jawa dan kemajuan teknologi, membuat kota Surakarta saat ini dinobatkan menjadi kota paling nyaman untuk ditinggali di Indonesia menurut Ikatan Ahli Perencanaan Indonesia. Lokasi yang strategis membuat program studi pendidikan biologi Universitas Muhammadiyah Surakarta menawarkan lingkungan yang nyaman bagi mahasiswa untuk kegiatan belajar dan penelitian.
Program Studi Pendidikan Biologi FKIP UMS adalah salah satu lembaga penyelenggara pendidikan calon pendidik biologi yang profesional, islami, memberi arah perubahan ipteks, berjiwa wirausaha, serta berkarakter utama. Prodi Pendidikan Biologi FKIP UMS didukung oleh sarana dan prasarana yang sangat memadai, serta tenaga pendidik yang profesional di bidangnya. Mari bergabung bersama kami di Prodi Pendidikan Biologi FKIP UMS.
Menjadi bagian dari salah satu institusi pendidikan global, program studi pendidikan biologi Universitas Muhammadiyah Surakarta secara aktif mendatangkan para ilmuwan terkemuka dari seluruh dunia dalam berbagai aktivitas, seperti visiting profesor, seminar, kuliah tamu, dan kolaborasi riset. Selain itu, mahasiswa program studi pendidikan biologi Universitas Muhammadiyah Surakarta juga terlibat aktif dalam berbagai kegiatan, baik nasional hingga internasional, dengan tetap mempertahankan latar belakang budaya nasional. Selain dalam bidang pembelajaran, program studi pendidikan biologi Universitas Muhammadiyah Surakarta juga menyediakan akses untuk kegiatan penelitian yang berdampak besar pada masyarakat. Hal ini dibuktikan dengan banyaknya publikasi hasil penelitian dari sivitas akademika, baik yang bereputasi nasional hingga internasional. Selain itu, program studi pendidikan biologi Universitas Muhammadiyah Surakarta juga memberikan kesempatan pada sivitas akademika untuk berkontribusi terhadap kesejahteraan dan menyelesaikan permasalahan di lingkungan sekitar melalui berbagai kegiatan pengabdian masyarakat. Program studi pendidikan biologi Universitas Muhammadiyah Surakarta didukung oleh berbagai fasilitas sarana dan prasarana yang mendukung berbagai kegiatan pembelajaran dan penelitian. Dukungan tenaga pendidik yang kompeten dan staf pendukung yang profesional juga menjadi salah satu keunggulan program studi pendidikan biologi Universitas Muhammadiyah Surakarta untuk mewujudkan program studi yang berkualitas dan bereputasi internasional. Kombinasi dari berbagai keunggulan program studi pendidikan biologi Universitas Muhammadiyah Surakarta telah menghasilkan berbagai prestasi yang membanggakan, baik di tingkat nasional maupun internasional. Komitmen kami adalah untuk mewujudkan komunitas belajar yang mendukung talenta dari generasi muda untuk menjadi pendidik, peneliti, dan wirausaha yang profesional dan memegang teguh landasan keislaman sesuai dengan slogan kami, yaitu utama, unggul, terampil, aktif kreatif, mandiri, dan amanah.
Finally, we get into the main event. Let's welcome our invited speakers, Dr. Simon M. Blom, Ph.D. from Southern Cross University, Australia, Professor Nazia Jamil, Ph.D. from Associate Professor University of Punjab, Pakistan, and Dr. Vina Listiawati, Ph.D. from Universitas Muhammadiyah, Surakarta. All the presentation and discussion will be moderated by our moderator, Dr. Efri Roziati, Magister Science. Dr. Efri Roziati, Magister Science, time is yours.
Thank you very much. Hello, thank you very much for the timing. Good morning, everybody. A warm welcome to all of you joining us today for International Conference Biology, Education, Natural Science and Technology, Incobest, second 2024. The topic here, biological rules to solve the environmental issue. I will introduce myself. My name is Efri Roziati. I'm concerned in environmental biology. My expertise in lichens as environmental bioindicators. Today, I am your moderator for 3 great speakers today. Please welcome to Simon Blom. Hello, Simon. Are you hear my voice?
Yes, I can hear you. Hello.
Hello?
Can you hear me?
Okay. The second speaker is Nazia, Prof. Nazia Jamil. Professor Nazia, are you hear my voice?
I'm hearing.
Okay, thank you. And then Vina Listiawati, PhD. Hello, Vina. For those of you joining us online, we appreciate you being here virtually. Everybody, today we honor to have 3 great speakers. Dr. Simon Blom from Faculty of Education, Southern Cross University, Australia. Her focus on environmental and science education across sectors. Simon has been an educator for more than 20 years. So Simon is very expertise in her field. The title of the paper today is Embedded, Affected, and Connected Science Education for Sustainable World. The second speaker, Nazia Jamil, is Associate Professor in Genetics, addresses in Department of Microbiology and Molecular Genetics, University of Punjab, Pakistan. Her research, international and publications is so many books, and then teaching experience in genetics, microbials, DNA sequencing, PCR techniques. We can check it, her publication in national and international papers and proceedings. And then Professor Nazia Jamil will take the paper today is eco-friendly production of biodegradable plastics from waste biomass using bacteria. And then the third speaker is Vina Listiawati. Vina is concerned to marine and environmental science, PhD from University of Ryukyu, Japan. Her field is marine ecology. Research experience is climate change on coastal ecosystem, especially grassland ecosystem, seagrass, and coral reefs. The research is ecophysiology impact of warming and ocean acidification relationship between seagrass and sea urchins. Well, everybody, we're excited to hear our speaker. Before we get started, let's give a warm round applause together to our speaker. Thank you. Simon, are you ready to present your paper?
Yes, thank you.
Okay, everybody, the first presented is Simon Blom. The time is yours.
Thank you very much. And Salamat Pagi. Hello. I'll share my screen now. And welcome. So my paper today is called Embodied, Effective and Connected Science Education for a Sustainable World. Before I make a formal start, in my country, Australia, it is customary and respectful practice to take a moment to acknowledge country. This respects the traditional owners of the lands. So I do take a moment to acknowledge the Widjabul country as the country where Southern Cross University originated and grew, and from where it continues to grow. It seeded the growth of our Gumbanya campus in Coffs Harbour, our Yugambeh campus in Coolangatta, and it planted the seeds to transform the countries we are on. We acknowledge and pay respect to the ancestors and descendants of the lands upon which we work, meet and study. We are mindful that within and without the buildings, the land always was and always will be Aboriginal land. So I will make a start with my presentation today. Thank you all for having me. I enjoyed the welcome videos and I enjoyed seeing the students out with the monkeys on the beaches. Very beautiful to see that happening. So in 2020, I started a project exploring teachers' perceptions of nature and how it informed their pedagogy. So for this keynote presentation, I'll be discussing this paper and the findings from this paper. I was really interested in learning about teachers' perceptions of nature and how this influenced their practice in the classroom. Teachers play a crucial role in inspiring children and young people to adopt life paths in environmental fields. However, teachers' voices have been largely undervalued in research in Australia, generally where acts of policy development and reform are done to teachers rather than with them. In response, this research study sought to authentically work with teachers, to hear their views and opinions and have their voices heard. More specifically, this study opted to work with early school years teachers, given the vital influence they have in establishing the foundations for children and young people's ongoing values and thinking towards environmental issues and sustainability. During my many 25 years teaching and working in environmental education, it has been interesting to observe what I saw as so many contradictions between what people said and how they lived. Moreover, I had my eyes widely open during a workshop presentation where I learned about many of the greenwash lies that are perpetuated through the way society might adopt certain practices, such as when you consider the life cycle analysis of certain products, for example, cloth versus disposable nappies. The results are not always what we have perceived them to be. My original research in this project is explored the question, and what I'm relating this to today is an embodied, effective and connected science education for a sustainable world in this paper. So my research was underpinned by a diffractive qualitative methodology. And so I use these diffractive rings to be symbolic of that. I first investigated the three areas of scholarship through the extant research literature on childhood, environmental education, and teachers' environmental perceptions and practice. Childhood explored a number of lenses, including childhood studies, the new sociology of childhood, philosophy of childhood, and the post-human child, as proposed by Karen Muris in 2016. The latter position The latter positions the concept of the child as a series and fierce part of their future world, where human and non-human nature relations are prioritized and lived. Environmental education explored the foundation of Western ideas about environmental education, from early Greek philosophy to emergent trends in post-humanism. It is acknowledged here that First Nations peoples lived environmental education before it was conceptualized in Western culture. Indigenous knowledges promote that environmental education is part of life, not separate from it, and it is entangled in every aspect of life, with and as country. In exploring teachers' environmental perceptions and praxis, the plethora of extant literature was acknowledged in this field. However, the dearth of research investigating teachers' perceptions as nature was evident. Teachers' praxis still centered on, for, in, and about, sometimes with, but rarely as nature or the environment. Relationality was identified as an opportunity to authentically address the notion of the theory-practice gap. So with an overarching post-human perspective, which is shared by quantum physicist and feminist theorist Karen Barad, challenges human exceptionalism and also requires humans to be accountable for the way we position the human amongst other creatures. This highlights the responsibility of the human in relation equally with the living and non-living. The tension that is created by working with post-human theorizing in an education system founded on humanistic principles is highlighted by Snarzer and Weaver, and I accepted that I would be dwelling in this tension through undertaking this project. The three concepts that informed this post-human theoretical framework were, as displayed on the screen, childhood nature. The premise of this theory is that it challenges binaries and distinctions, such as those between teacher and student, adult and child, and childhood and nature. Material discursive practice, as proposed by Karen Barad, accounts for the agency of matter. Karen Barad explains an example by stating that, on a quantum level, when you turn the light on in a room, you have rearranged the furniture. When light bounces off a relatively large object, the disturbance it imparts is negligible relative to the accuracy of the measurement. That is, it is often the case that any such disturbance is too small to notice. For example, we don't notice the furniture being rearranged in the room when we turn the light on in a dark room, although that is strictly the case. Karen Muris, Snarzer and Weaver and others have used this concept of material discursive practice in educational research. An example that best describes this theory is, wherever educational research is conducted in schools, there is much more going on than the interaction between a teacher and students, or teachers and teachers, or student and students. There are experiences happening all the time, all over the school, independent of humans. There are always interactions between humans and non-human sentient beings, and humans and non-sentient objects, such as computers, doors, playgrounds, hallways, utensils, trays, balls, windows, desks, and so on. This is the theory of affective atmosphere. It's best described as the feeling, mood, or vibe that is present in a space. It is a theory which is taken from geography, and I invite you to interact with affective atmospheres now. It is about how you feel and what you sense around you, what you sense from the outside. It's different connecting with our emotions. It's our affective sensitivity. So instead, you focus on the 5 senses. And I encourage you to think about what this might mean for your classroom and in your teaching. In Australia, there are many outdated narratives and paradigms in science education that continue to perpetuate environmental philosophies and actions, that are not conducive to a sustainable future. In the Australian science curriculum, nature is considered as something out there, as a commodity to be used and often exploited in the name of human advance and human gain. 2. There is a large drive in Australia for students to engage in information communication technology and digital learning. There is not a similar priority for students to spend time in nature. It could be inferred that prioritising digital technology over nature demonstrates what the adults and decision makers care about, and in turn, does not role model what is crucially important, that is, connection to nature and the natural environment. 3. The human and nature interactions described in science are traditionally transactional, the use of nature for humans, rather than a focus on developing meaningful relations between humans and nature. Science and nature are taught removed from the human. It is entangled with, meaning there is no connection through embodiment. Science does not teach us how to deeply connect to our own human body, to listen to its cues and attune more deeply to the natural environment. Instead of being interdisciplinary as it is designed to be, unfortunately in Australia, sustainability is generally taught through the science and sometimes geography curriculum. So the research that I conducted adopted a diffractive ethnographic methodological approach. So it was an ethnographic study, which comes from anthropology. It's very traditionally human-centered and does look at humans within their cultural and social settings. I conducted this research with 4 early school years classroom teachers and teaching principals. The purpose of using low participant numbers is to do a deep dive, so you get to spend a lot of time with the participants during the research project. A number of methods were adopted, including lesson observations, which I called lesson participations, to acknowledge the place of the researcher intrinsically embedded in the research. Video recalled interviews, which were conversations without the structured or semi-structured framework. They responded to a video recording of the lesson participation. The researcher and participants conducted visual journaling to document their experience with nature through the period of the project. The researcher took videos, photographs, and field notes during the participations, and other documentation such as emails and school newsletters were included as data in the project. There were 4 phases for the data collection and analysis, and I'll now share some of the data from the 4 participants. So Roger, which is a pseudonym for one of the participants, discussed teaching about nature and sustainability. And he said, "I would like to teach sustainable practices, although they are quite isolated within those science lessons. When I'm teaching those, the science lessons, the ideas will come up a lot more, and then they'll be discussed and taught explicitly. As teachers are bound, limited, or perhaps even censored by the curriculum, what does it mean if teachers are addressing sustainability only through science? I provide the example of a grade 1 and 2 primary syllabus outcome, where stage 1 of the Living World strand focuses on the features of living things, their environment, and how they change and reproduce. Students investigate how plants and animals are used to satisfy our needs for food and fibre. Stage 1 of this strand develops students' understanding of how living things and their environment play a central role in the support for and survival of humans. In these outcomes, you can see that nature is considered to be a commodity to be used, and perhaps even exploited through the terminology of satisfying our needs. Nature relations are then considered at a transactional interaction level at best. Relationality, that is, the importance of developing a relationship with nature that is appreciative and mutually beneficial, is not mentioned. While teachers are also supposed to address the sustainability cross-curriculum priority, which is an overarching set of organising ideas that are supposed to be embedded into each of the disciplines, this research that I conducted demonstrated that most teachers are not explicitly and actively doing that. One of the participants, Lillian, had frustration at the education system. This is demonstrated through this conversation and demonstrates the lack of support that is available to teachers and principals. This situation is shown through research that focuses on the challenges for teachers in implementing the sustainability cross-curriculum priority, including lack of scaffolding and support. So I'll just read Lillian's response. When the sustainability cross-curricular priority in the Australian curriculum first came out, it was overwhelming because it meant every teacher at every stage had to totally restructure their approach in terms of how you embedded the Indigenous perspectives in sustainability. And people tried, but they were going, how are we actually going to do it? Because there was no direction to it, there was a direction to it, but not a lot of resources came out. Or the resources sounded useful, but they weren't. They weren't classroom based, or they were, here's a great website, now I've helped you, or here's a research article, now we've helped you. That's about it actually that I can recall. They may have done some more useful things, but I can't recall any useful document prepared by the Department of Education for a K-6 teaching environment in any discipline because it's too hard. So the sustainability cross-curricular priority was demonstrated to be evident in Lillian's lessons, such as through a lesson about Australian wildlife that included many of the 9 organising ideas from the Australian curriculum. However, Lillian's awareness of when and how this is achieved is not at the forefront of her thinking. It seems largely due to the unclear and explicit way that the cross-curricular priorities have been implemented. So from the second organising idea, all life forms, including human life, are connected through ecosystems on which they depend for their well-being and survival. So Caitlin shared on the sustainability cross-curricular priority that maybe people don't understand it themselves. You know what I mean? I think it's the same for Aboriginal education. If they don't understand it, they don't really want to do it. Like they tick the box and go, oh yeah, I've done that, but it's not really integrated into everything. And I think maybe sustainability is the same. It's this hot word that everyone's talking about and everyone wants to do it, but some people think it's hippie or some people think it's alternative. You know, it's quite complex. So doing it in school, how do we do it properly? And how do we actually do it justice? I think people think that gardening is being sustainable because that's the breadth of their knowledge. Barnes et al. Highlight the fact that sustainability placed as a cross-curricular priority means that there is no explicit requirement or accountability for how the content is being implemented, taught, or whether or not it is being taught at all. Their study concluded that sustainability is not a priority, nor is it cross-curricular. Their suggestion is that a different approach is needed. Resources to support teachers and school leaders to implement the sustainability cross-curricular priority are lacking, and as a result, sustainability is silenced. However, it is also evident that teachers do implement the sustainability cross-curricular priorities organising ideas in their lessons. So while the sustainability cross-curricular priority is being implemented, the concern is not whether teachers are putting that priority into place, because evidently they are. Rather, it is the lack of engagement, enthusiasm, and awareness that is most alarming. 2 participants demonstrated incorporating the sustainability cross-curricular priority into their science and technology lessons through the curriculum during the lesson participations. De Silva Branco and Woods McConney identified the close links between the sustainability cross-curricular priority and the science curriculum. However, Henderson stated that sustainability icon is only tagged 8 times in the science curriculum, compared to 16 times in the humanities and the social sciences. It is clear that teachers are feeling the bounds and the constraints of the current curriculum, while research in science and sustainability education may be too focused on making sustainability concepts more accountable through the disciplines. The very content that is considered to be about sustainability in the science curriculum is maintaining business as usual approaches and not moving with current times on ecological and societal levels. One teacher did not want to enact a didactic approach to teaching about sustainability through explicit teaching, and as part of their program, they weren't required to specifically meet the outcomes. The lack of outcomes-based and outcomes-driven content enabled this teacher to adopt a rich, authentic, student-centered approach to the program, which responded to students' interests and ideas. The students were given control and were called team teachers. Moreover, this specialist sustainability teacher collaborated with classroom teachers to complement student learning while ensuring the program remained in the hands of the students. Other teachers were invited to collaborate through the utilisation of the outdoor learning spaces for activities such as measuring plant growth in maths, or as a place for students to take a break from the classroom to connect and recalibrate. Although practical-based application, the specialist sustainability teacher facilitated and engaged students in a range of sustainability activities, specifically designed to develop and enhance their future and understanding of the environment and nature, while addressing the futures section of the sustainability cross-curricular priority, which comprises of 4 action-focused organising ideas designed to work towards a more sustainable future. Sustainability education was often shown to be implied rather than explicit, while the notion of implicit teaching of values has been explored through the literature. There is a dearth of research that identifies how teachers are teaching sustainability intrinsically without specific planning or consideration. It was evident for all 4 teachers in this study that the sustainability cross-curricular priority did inform their perception of nature, nor their pedagogy or even their programming. However, the sustainability cross-curricular priority organising ideas were evident in each of the lesson participations. There is a clear need for further research into the extent to which teachers are implicitly implementing sustainability and how a more socially, contextually appropriate, contemporary and inspiring curriculum would work in both informing teachers' perceptions of nature and their pedagogy. Caitlin also shared, science at the moment is all based around sustainability and growth. So I think, yeah, I'm addressing it, but do I know that it's sustainability? It still feels detached from the whole concept, even though it's all about conservation and sustainability. I don't know, there still feels like there's some mismatch. There's got to be a different way that's more meaningful and not just this same, it doesn't feel very ingenious. Maybe that's where the mismatch is that you're trying to reinvent the wheel to think differently about it, how to fit sustainability into the curriculum, but just making it more meaningful in the classroom. There's no groundwork for how sustainability fits there. I'm going to take a slight turn now and talk about digital technology in the sustainability curriculum. In the age of digital media, direct aesthetic experience with the natural world may seem like a simplistic or even unrealistic educational touchstone. Many educators today are encouraged to engage children with the wonders of technology rather than the wonders of nature, as said by Greenwood, which was why I was so excited to see all your students with the monkeys and the beach today in your video. It has been well documented in the research that one of the contributing factors to children not spending direct time in and with non-human nature is due to being indoors with digital technology. Moreover, Khan et al. Assert that digital technologies provide a distraction from the external environment and offer a way for people to tune out rather than attuning to and tuning into nature. One teacher participant highlighted that they enjoyed being in nature as it provided a space void of technology, and as such, they opened the windows in their classroom to let nature in. However, in contrast, that same teacher adopted the use of technology as a behaviour management tool. Caitlin shares her experience with her son. He's an outdoor kid. If he can just be playing outside with the chickens and fishing and catching lizards and looking after frogs all day, he's the happiest human being in the world. Whereas he's in trouble at school all the time, and then they put him on a behavior plan and took him out of the playground. And I just thought, what are you doing? But you can't argue. But you're taking the nature out of my child, and they are. Being outdoors, exploring nature allows him to connect with himself. He has settled into year one really well, but he has a stronger urge for technology, gaming, YouTube, and devices. I can't help but wonder, has school begun the process of conforming his connection to nature out of him? These two examples of disconnect, the benefits of nature contrasted by the digital classroom and a child's need for the outdoors while consistently being removed from it, highlight that a very basic fundamental shift is needed to consolidate these conflicting and confusing discrepancies. The movement to learning in nature was very evident in two teachers' practices. One teacher highlighted that technology is a distraction for students and advocated for and implemented having students outside in nature, learning by doing practical, meaningful tasks. The shift, which began with the New Nature movement by Richard Louv in 2006 and getting children outside, needs to look to the details of how teachers embody and facilitate the concept of human bodies as nature, rather than education in nature being seen as a beneficial act of restoration and connection. Outdoor experiences can be reconceptualized as an enactment of returning the human body to a place where it is naturally from and belongs. In Caitlin's classroom, technology is not just digital. Technology involves exploring the school grounds and using the natural environment as a way to think about design techniques and structures. The importance of affect. Hence, the spaces of affect and feeling, including their material elements, are extremely important because they provide us with an understanding of affects as embodied and unlearned practices. That's by Zembales in 2020. And I love these images because they represent the awe and wonder and magic of nature that is so simple and easy to return to. And I draw on a quote from Rachel Carson from 1965 when she proposed that it is not half so important to know as to feel, and that the development of sensitivity in all its rawness and exposure is what is needed to connect more with our environment. Malone and Moore in 2019 suggest a sensing ecologically to describe the way children's bodies engage and communicate with a more than human world prior to the language acquisition. I would argue that adults too are sensitive to the ecological, such that bodily communication is a process of meaning making, where bodies sensing and recognizing other bodies is where sense making is activated. David Sabel claimed that adults need to give children time to reconnect with nature and love the earth before we ask them to save it. And Calvitis and Monhart further asserted that affect is required to motivate people to act in environmental education. One teacher in my research study valued time spent in nature for all the benefits and lessons it has to offer, and also personally as a time of connection with self. Moreover, appreciation and awe of the natural world was evident in the teaching and learning, which was all outdoors, environmentally focused, active, and agentic. Perhaps time spent in nature, with space to enjoy it and appreciate what it affectively offers, could be a process of attunement of human bodies to each other and the non-human bodies that are in constant interaction. Our cells are in constant communication throughout our bodies, just as the biological matter is in the natural world. Marco Bischoff discusses biophotons, which is the way that light is produced by the human body's cells and is a significant contributor to our inner makeup and how we communicate with the external environment. On an even more micro scale, the atoms that make up our body are never not connected to every other human through our interconnected particles. Karen Barad discusses the way our particles are always already connected. Consider how our particles of my body interact with the air around me and with another person when we're in the same vicinity. There is always more communication than just what we see and what we say with our macro body. Paying attention to the affective provides an opportunity to consider how we experience environments, from a loud, busy classroom to a quiet library or natural space. Beginning to understand how we feel in nature compared to how we feel in other environments is one way of returning power and authority to our bodies and listening more attentively to what they have to say. So what does this mean for practice? Science and biology education have a pivotal role. They enable us to develop a deeper understanding of the natural world, including our place within it. They facilitate experiences for greater embodiment of the affectivities of nature. They enable us to develop an awareness of what the human body as nature is communicating. And they enable us to explore how the science syllabus and curriculum can be reconceptualized to be more explicitly working with human bodies as nature and in relationship, not removed from or exploiting all that nature has to offer. And my biggest focus is about reconnecting to our human bodies as nature and thinking about how we can, through our greater embodiment, experience and be sensitive to the affectivities of nature and appreciate it, enjoy it more fully. I know there's been a little bit of talking over the top. Am I okay to continue? I've just got a couple more minutes. Yeah, okay, I'll continue. So from this research, I have a book in press that will be released early next year, and that's through the Post-Qualitative New Materialist and Critical Post-Humanist Research book series. I also have a paper that I published not long ago called Education in the Changing Climate, Reconceptualizing School and Classroom Climate Through the Fiery Atmospheres of Australia's Black Summer, which talks more about affective atmospheres and what this looks like in the classroom. So I just put the QR code up there if you're interested. And there are a couple of slides of references if you wanted to read more deeply into any of the literature that I presented during my presentation. And the second one. And I do have a couple of slides of some of the other work I've done, which I can share with you if you're interested. Just a bit of background work. I did a module that's actually been translated into Indonesian, which is about STEM education, and you can look it up through this QR code. I've also created another STEM module called the S.Si, Southern Cross University Electric Combi Conversion, that uses the iSTEM process. And I've also created a regenerative agriculture professional learning for teachers, which is an all online module that teachers can engage in to do professional learning about regenerative agriculture, which is the idea that we can remove inputs and make farming more holistic and better for the natural environment. And that is the end of my presentation. Terima kasih.
Okay.
Bioplastic, biopolymers, eco-friendly production of biodegradable plastics from waste biomass using bacteria. Your time is yours, Prof. Nazia.
Thank you.
Okay.
I'm sharing the screen.
Yes.
So is it okay? It's visible?
Yes, that's great, Nazia.
Yes.
Okay. So I'm Dr. Nazia from Pakistan Institute of Microbiology and Molecular Genetics. The topic of my just a minute. What's happening here? आप यहाँ से चली जाओ. The topic of the title of the talk is the eco-friendly production of the biodegradable plastics from the waste biomass. The whole theme of this one, the whole research work is about the how we are going to replace the conventional plastics, that is the petro-based plastics, with the biodegradable plastics by using the cost-effective or cheap carbon sources for bacteria. So we use in this whole study, we use the bacteria for the production of the biodegradable plastics. And in this one, we discuss the different projects on which we are working. So in short, over here, we all know about the plastics, that how this is the dilemma of the terrestrial and the marine life. And it is a very big problem. And it is actually the plastics are increasing at an alarming rates. It has disposable problems. If we are going for the incineration for the these conventional plastics, it produces different chemicals which are also the environmental problems. And these plastics which we usually use in our daily life, these are petro-based. These are not, they are resistant to the microbial degradations and persist in the environment, in the terrestrial lives, and in the marine. So why we need this and the basics of the bioplastics? Actually, plastics, those plastics which are petro-based or the non-degradable are the major threat to our environment. So these are the big problems. Every piece of the plastic which made within the last century is still persist in the environment somewhere in the earth or in the environment in the form of the microplastics. If they get degraded, so the environment is in a terrible situation nowadays. The development of the bio-based plastics with a more eco-friendly alternative for the production of the packaging and the single-use items. Actually, the most those products which we use is the single-use items. And if they are the petro-based, they persist. And if we use them as a bio-based or biodegradable plastics, then we can see, okay, these are going to go for the biodegradation. So the increasing nowadays, the industry for steadily grow for the global bioplastic productions, and it is about to be the 2.44 million tons in 2022. Bioplastic could be replaced any disposable items made from the plastic, such as the cutlery, packaging. Nowadays, these are actually in the use. So what actually the bioplastics are? Term bioplastics can be applied to any plastic material that is primarily derived from the renewable organic materials. The biodegradable plastics on which we are working here in Pakistan are the polyhydroxy alketonoids. Actually, these are the inclusion bodies present in the bacteria, and these are used as storage or the energy reservoirs by the cells. PHs are produced by the different bacterial genera. Examples are the Pseudomonas, Agrobacterium, Bacillus, and all these. The chemical composition of the PHA depends on the biosynthetic pathway and enzymes needed for the PHA production. Actually, the chemical composition means that how the bacteria use the substrate and which type of these are producing. This is the picture of the one of the benchmark work of the biodegradable plastics, how these are degraded in the, and this is the item from the biopol IRTM by the incubation in the mud for the 80 days, and how these are degraded. Actually, the degradation and all these things are get controlled by adding or by the substrate manipulations. We can change the nature and the degradation process as well. So the PHA or the biodegradable plastic, that is the polyhydroxy alketonoids, are of the three different types. The short-term chain, the short chain length, that is the SCL, medium chain, and the long chain. Usually the medium chain length PHAs are used for the different productions. Polyhydroxy alketonates are mostly produced under nutrition limitation conditions, surplus carbon contents, and low nitrogen, magnesium, and phosphorus contents. The biosynthesis and the degradation of the intracellular PHA occurs in the cell simultaneously. As these are the storage materials, so they are also degraded. The strategy which we are usually using for the extraction and for the production of this one is on the different stages. That is the stage 1, 2, 3, and 4, 5. In the stage 1, we collect the different samples and then we screen them out. Then the production and optimization process having over there. Then the stage 4 structural elucidation, that is the characterization of those biopolymers. And then the stage 5, we go for the genetics, and then we move towards its feasibility, that how we are going to exploit them for the stage of pilot scale productions. So in the stage 1, the sample collection, we collected different samples from the contaminated sites. That is usually the contaminated waters or oil, waste, frying oil, contaminated sites, soil from the dumping sites of the PAT or the or the plastic, sludge or the wastewater or agriculture waste, where the agriculture waste are dumped for different many years, from past many years. So we are collected the samples from there, so we can isolate bacteria from those, and then we provide the same contaminant as a carbon source, so they can use that contaminant for the production of the PHA. So development of the renewable sources for such type of the bioplastic substrates are required for microbial proliferations and the PHA production that are the renewable, cheap, and easily available in the environment. Large amount of the waste effluent discharge, agriculture and food processing units. These waste effluents contain many nutrients in them. Inexpensive substrate management for the PHA production helps in the all these, if we consider all these things, and then we go for the cost reduction, because actually why not we have that much biodegradable plastic now till now, due to its because that is very expensive and not cost effective. So we can use the cost for the reduction of the cost, we can use the cheap carbon sources. So under the stage 2, what we after the collection and all that stuff, we go for the screening. After the collection of the different samples under the sterilized conditions, we go for the screening, that is the isolation of the bacteria from those samples. And we analyze them, that how after the isolation and purification of the bacteria, we check them, we screen them under different UV, microscopic, that is the under electron microscope, or under UV colorization stainings, that is the Sudan black staining under light microscope, and then the Nile blue staining for the UV, which gives the which shows that these bacteria accumulates the PHA inside them as a granule by producing the fluorescence, and those fluorescence indicates that this type of the PHA is accumulated in this one. This is also one of the detection agar media, in which we provide the Nile blue about to be the 5 microgram per ml, and then we spreading this direct sampling. We also collect the bacteria by direct sampling on the petroplates, and if those bacteria which produces fluorescence, we isolate them. Then this is one of the analysis for the in which this is one of the site from contaminated site. We collect the samples and we check that the how many what are the different percentages for the pH positive bacteria, and we check that after the whole screening process, we find out that the 88% from that site, that is this site is contaminated with the oil ghee contamination site near the Gujranwala, Pakistan. What is this one? Where the oil, there are the different factories for producing the oil and the ghee, and which contaminates their soil, and oil are dispersed all over in the water and in the soil. We collect the samples from there. We isolate the bacteria and we provide them the oil and ghee, and they gave us the positive results, that is about the 88%. And a bit more interestingly, that all the bacteria which are there, they are producing in a different way. Sometimes they are producing 2 or 3 or 4 granules inside them, which is for the pH, from which after that we are going to extract them. So these results, just the screening result, that okay, that much bacteria has positivity for the bioplastic productions. Then in this third stage, what we these are all the generalized steps actually. In this stage is the very crucial, very important, that in which we all those bacteria in one under one project, we screen. After the screening, after the scrutinizing, we take them we take them for the production and their optimization on the cheap carbon sources, that is the inexpensive carbon sources. We change their pH, that at which temperature, pressure, or at which temperature or carbon nitrogen ratios they are producing the highest amounts of the pHs in them. Then the for economically production, for economically feasibility for the PHAs, to produce them economically feasible, we have to produce the PHA comparable to the prices of the petroleum-based plastics. We should find possible ways to lower the final price of the PHAs at the customers, and factors responsible for high price of the PHAs, PHA productivity methods, actually the PHA productivity, that how much that bacteria is producing, what is the process of the recovery, and the cultivation strategies. Should all these costs should be under control, low cost, all phenomena should be at the low cost. Choice of the strain is also counts very, very important, carbon substrate cost. These are the selection of the different carbon sources. What different carbon sources which we usually use? We usually use by in view that from where we are isolating. If we are isolating from the oil contaminants, then we provide them the oils, and we usually, at the first place, we provide them the glucose and check them either they are positive for the PHA production. So all these show over here. We use the carbon sources like the molasses. In the agriculture waste, we use the molasses, bagasse, sugarcane juice, sugarcane molasses, potato extract, oils, wastewater, and glycerol, and many other. And nowadays we are also working on all that from the dumping side of the plastics. We isolate the bacteria and we use those plastic as a carbon source. So we are growing our bacteria on the plastic, which is the problem, and they are producing a biodegradable plastic. So nowadays we are working on that one. But these are all these are the biomasses, biomass from the agriculture, related to agriculture wastes. The methodology usually we used for the production of the PHA is either we go for the single bacteria or two or combination of two or more co-cultures, or the mixed cultures, many different genera mixed cultures. We grow them in the open or in the closed environments. Closed environments is always the expensive one, and the open environment is usually the cost-effective one. This is about the industrial scale productions biopol one, which I show earlier, the degradation of the bottles. They use the combination of the glucose and the propionic acid. One of our project with the Australian university, that the Queensland University. In this one, we use activated sludge. This work is done with Dr. Stephen in Queensland University, Australia. Activated sludge, which is on which we work in collaboration with them, is from the Brisbane. In this project, what we did is the collection of the activated sludge, and we isolate the bacteria collectively and analyze them for the production of the PHAs, the biodegradable plastics. And we also use the waste water for the production of the PHA. Like substrate used in the sludge are the valerates, propionates, and the butyrates and the lactates. This is the setup of the for the production of the biodegradable plastic in collaboration. That is, this picture shows the sludge from where directly the samples were collected. This one is the lab setup in which we used, and this is the production of the PHA by using the wastewater, only the wastewater and the bacteria, and they are using that wastewater for the production of the bioplastics. These are the different bacterial strains which use the oils. Like I earlier shows the slide in which the bacteria which was isolated, we characterize them and we submit for and get their accession numbers, sequence them all, their whole genomes are with us, and we are trying to exploit for the industrial purposes the strains which we have isolated from the oils, and they are using oil for their PHA production are Bacillus, Klebsiella, and the Brevibacterium, Pseudomonas, aerogenus, and Stenotrophomonas. And all these strains are with us, and we are working on them. All strains were PHA producers, so were selected for the PHA synthesis using the different carbon sources. In these strains are also used, they are also using the waste frying oil. That is usually we use in the market, and they discarded as it is. We take the frying oil from them and we feed the bacteria on the waste frying oil for the production of these bioplastics. Another project is the same project on the different vegetable oils. These two strains producing up to 53% dry weight, which is from the waste frying oil. They are producing 53%, and it is quite promising for further investigations at the larger scale. And in the same manner, the strain, this is also the one of the Bacillus strain, STN7. It is also producing about to be the 27% on the same waste frying oil. These are the different bacteria using different carbon sources, agriculture, bio-based source carbon substrates, which they are using and producing the pH. This is from all over the world. This is one of our project in which we use the molasses, palm oil, crumbs, and whey for the production. And what we find over here is the molasses. showing the highest, if we are using the molasses, this one, MFD 11, producing at the highest rate, about to be the 40 or 50% of their cell dry weight. That is the PHA. This is the production on the mustard oil. This is the setup in our lab for the, this is the fermenter, 5-liter fermenter for double jacket. In this fermenter, we use different substrates. This setup at this moment is showing for the mustard oil. We also use mustard oil and for their production, for the PHA production. And then this is the this one is from the co-culture. In this we use in this one the glucose and the 10% wastewater. 2% glucose with 10% wastewater in a media, and strain is the Bacillus halotolerant. This bacteria is very promising, accumulating in this way. This is the bacteria, and these granules are showing that the whole bacteria has a bunch of granules in them, and this one producing highest percentage, about to be the 60 to 80% of their cell dry weight accumulating. All these studies, if the bacteria accumulating more, then it is very easy for our extraction, and we are getting the good films for those bioplastics. This is the co-cultures of the two bacterial strains. That is the WK, this one, and the 14SM. One of the project is also with one of the my postdoctoral fellow, Dr. Tammy Tope from Nigeria. She got the scholarship from ICGB, scholarship, postdoctoral fellowship from there. She get the funded from there, Sweden, and came to Pakistan for doing this bioplastic production. She get the cassava plants with her, and the cassava in which they we use that their peels and shafts for the production of the PHA. And she also has the bacterial strains with them. We characterize here, we do their genetics, either they are exactly the producing, we did their optimization, and we check their biofilms. We check also the PHA, that is the bioplastic films also. This is one of her results, in which that the highest rates of the production of the PHA. Green line shows the grams of the grams per liter. After all these carbon, nitrogen conditions and all that stuff, we go for the stage 4, that after the extraction and all that stuff, after the optimization, we get the bacteria after the centrifugation, and we apply towards the lyophilization and extraction processes. That now we are at the stage of the extraction of the biofilm, the thin films. These are the different methods which we use previously, and nowadays we also use the non-solvent extractions as well. These are the solvent-based techniques in which we use one of the solvent, that is the chloroform. But before that, what we did, that we grow the bacteria, collect their biomass, dry them out either by the lyophilization, sonication, lyophilization, or air dry. And after all that process, we either treated directly with the chloroform, or we crush them out with the sonication, or lyse them with this SDS method. And after the centrifugation, collecting the different layers, and we extract with the chloroform. And after the of all that process, what we got, the films of the bioplastics like this. In this one, what at the end, after the precipitation with the methanol, what we get is the thin films, as we want to shape them out, but they are bits fragile due to if we do the at the low, that is if their volumes are very low, then we extract them like this, and they rupture from there. And if their volumes are increased and biomass is very good, then we get the plain, without rupturing, without tearing, we get the films. This is also one of the example of the Pseudomonas aeruginosa. This is also one of the batch cultures, open mixed fermentation using 50% wastewater, 50% PHA media. What we did over here, actually the chemistry, a lot of chemistry over there, and a lot of laborious works is there. In this one, we apply the open cultures, non-sterilized conditions we provide them, and the mixed culture fermentations and all that, and we get the 68% in 24 hours in the mixed cultures. This is one of the also the chemical characterization of the polymer obtained from the co-cultures, bacterial strains. And what we find over here, we did the proton of these bacteria and their FTIRs and all that all these things, and confirm that these are the medium chains, and they are the PHBV polymer. After this chemistry, we find out that these are the copolymers. And one of the interesting thing also is that when we grow these mixed cultures or co-cultures, sometimes they give us the co-productions. That is, we are getting the two type of the productions. One is the PHA, that is the bioplastic, and side by side we are also getting the exopolysaccharides, which are which we can exploit as well for the side products as well. So after as we find out when we grow these bacterials, we get the films from these mixed cultures. We are always at the threat that maybe these are toxic, these are not going to be used for further processes of, in the for their toxicity. Either they are toxic or not, either they are non-toxic for further exploitations. We do their cytotoxicity test, evaluation of the copolymers, or whatever be the films we get. We usually perform the MTTT assay for their toxicity test, that these films are non-toxic by the survival rate of the cells. These are the different metabolic. This is one of the metabolic pathway, which shows the metabolic pathway involved in the biosynthesis of P3-HBE, which is previously I show their electron, and now the pathway by which they are using and producing the copolymer. After all that extraction and all that assays and the spectrophotometer and all these stuff, we all did all these things. This is these are the films from the potato extracts. As by bacteria, using, we provide the potato, their peels, and we extract the their starch and provide to the bacteria. And the plastic which we are getting is of the fine white thin layers, and we check them and prove after the structural elucidation, we find out that yes, these are the medium chain PHAs, and these can be exploited. This is their one of the proton NMR. After all this stuff and all these things, we are go for the visualization that actually at which stage they are accumulating the bioplastic inside them. This is one of the picture of many of the TEM, that is a transmission electron micrographs. We can observe from here that how much of this bacteria is accumulating the bioplastic inside them. Mostly it's 80 to 90% of its whole volume of the bacterial cell is accumulating this one, the bioplastic inside them. And at this stage come after about to be the 24 to 48 hours. And at this stage, cells are very, very fragile, and we have to take care. If we delay in the extraction processes, this might be get leak in the media. And this bacteria also shows the co-production of the EPS, which is very visible from here in the trend. This is also one of the bacterial strain. This one is the mixed culture, and in this one, in the previous one, there is a one granule, and this bacteria is accumulating by using the glucose and the propionic acid. This one is on the waste sludge, that is which in the earlier I show. This is the electron micrograph of that one bacteria, which we isolate and culture them in the mixed cultures. In this one, they are accumulating pattern is like this, that they are accumulating in many granules, and we after extraction, these granules get extracted, and films are formed from these granules. In the stage 5, this either we stop at that stage or we move towards that, that what are their metabolic pathways, or actually when we go for the long-term checking of their feasibility, we go for their molecular analysis as well for the confirmation of the strains. After the identification with the 16S RNA, we go for their genomes. We do the different methods for their genome, either the whole genome or the different genes. We amplify with the PCRs, and we perform different PCR for the PHA polymerases. We isolate them, analyze them, and check them which type of that PHA synthase gene, and what exploitation we can did, and how we are going to modify this. One of the work which I fully based on is on the nature. That is, I am not go for the genetic engineering processes. I always use the naturally occurring bacteria, and I'm not going to change their genomes. I'm not changing their not editing their genomes. I'm using as it is, but just providing the substrates and exploiting their nature. That's it. I'm not changing their genomes because I'm not believe on the GMOs. So I'm on the nature and the natural processes. These are the different sequences we've submitted. This is the this is one of the figure of the class 4, which is the long chain PHA synthesis, and the R genes, which we sequence and did their whole genomes. And we find out that these genes are accession numbers which we get for the whole genomes are the class 4 operons, and the PHAR for the, this is also belong from the class 4 operon. One of my recently in 2022, we did the whole genome sequencing of one of my bacterial strain, that is the Bacillus halotolerant, and we isolated from the hot spring from where we isolate and then sequence, and this bacteria is very yeah, has very much applications in also the plant growth promotion. This bacteria also do the plant growth promotion in the wheat, and we also get the different combinations, and this bacteria always perform the best one. So that's why we did its whole genome, that what different things are present in this one and how we go for that. In the stage 6, that how we are going to exploit them or in different types. So these are the different applications in which we can use them for the production of the disposable cups and the implants and many different things in medical and many other different things. So in conclusion, we do the bioplastics for quantitative analysis, synthesis of the pHs. Qualitatively, we analyze and we check their synthase genes for the production of the bioplastics by using different agro-based, bio-based substrates. This is one of our book which we published is about the soil microenvironments for bioremediation and polymer production. And these are the different different research projects which we are doing and completed, and we also do the work on the MDR-TB also and the mobile genetic elements. I also get the projects from the IFS and other from higher education, from NRPUs and all that stuff. These are the my collaborators. My research work gets supported by ICGB, IFS, Punjab University, Higher Education Commission. I have the collaboration with Professor Juliana Ramsey. She's very cooperative, and we did carbon nitrogen source work with them. Dr. Nehel from USA, Dr. Thomas. He's very nice person from Poland, and we did the MDR-TB work with him. The chemistry work we did with the Chemistry Institute's transmission with the Scotland University, Dundee University, and then Macrogen, and then NIBGNIAB and FESLA. We did all these works. This is the student from the Nigeria, came to as a postdoc with us. These are my students. Thank you very much for your attention. Thank you very much for inviting me as an invited speaker. I'm very proud or congratulate you people that you are organizing such a nice conference, and very good organization without any disturbance. It is there. Thank you very much. Thank you. Thank you, Dr. Joseph. Thank you, everyone. Thank you.
Okay,
Thank you
thank
very
you,
much.
Professor.
Thank you. Is there any questions so I can answer, or we can discuss something?
Thank you, for Nazia. It's a great.
Thank you. Thank you.
Maybe the next we will collaboration with your able.
Inshallah. I'm waiting for your response, and I'm there always with you people. And I'm very glad that I'm seeing you people doing your work very nicely, and it's very proud. I'm very proud.
Yes. Yes, your presentation is open our minds about the plastics can biodegradable by bacteria. So far, it's very neat to study in deep.
Yes.
Thank you, Professor Nazia.
Thank you. So nice of you.
Ladies and gentlemen, we'll welcome to the next speaker, Vina Listiawati, the third speaker. Vina will present the papers is about it's about acidification of two coral reefs. Vina, are you ready? Reminding to you, please prepare your question to the speakers, to Simon or Prof. Nazia or Vina. After this session, we will discuss opening the next Q&A session. Okay, Vina, are you ready?
Check.
Okay, this time is yours.
Okay, good morning, everyone. So it's an honor for me to talk here. So the talk that I will introduce today is a part of my research that I conducted during my PhD study at the University of the Ryukyus. So today I will introduce about the climate change impacts on coastal ecosystems. So coastal ecosystems is a zone where the land and ocean interact. So it's characterized by a diverse process such as storms, waves, currents, tides, and winds. And it encompasses a broad range of ecosystems. So here's the sum of type of a coastal ecosystem that we can find around the world, such as rocky shore intertidal, or the marshes, the estuary, the mangroves, the coral reefs, and also the seagrass beds. And the last two will be the major ecosystem that I will talk today. So the coastal ecosystem have so many ecosystem services. Here we group to 4 different services, such as the regulating, the supporting, the provisioning, and the cultural. For example, in the regulating services, we can have service such as carbon storage, storm protection, and etc. And in the supporting services, there is a food web, nutrient cycling, water cycling. And in the provisioning services, we can get the fish and shellfish stocks, the energy, the harvestable seaweed. And in the cultural, we can get the tourisms and recreation, the knowledge, and also, for example, the creativity and arts. So coastal ecosystem are the most productive ecosystem on Earth. So if we compare the coastal ecosystem with the terrestrial ecosystem, the coastal ecosystem only comprise a small percentage area on Earth compared to the terrestrial one, but it has a high net primary production. For example, here the algal beds and reefs is only comprise about 0.1%, but their productivity can be compared with the tropical rainforest. And coastal ecosystem also a very dynamic ecosystem. So if we compare the coastal ecosystem with the oceanic one, here, for example, the PCO2 concentration, in the oceanic ecosystem, the PCO2 are quite stable throughout the years. But at the coastal ecosystem, there is a high fluctuation in the PCO2 throughout the diurnal cycles. So next, here I will give a brief introduction about the coral reef ecosystem. So coral reef are some of the most diverse ecosystem. where the coral polyps, the animals that primarily responsible for the building reefs, it can have many forms in this ecosystem, such as building the large reef colonies, fans, and also just small solitary organisms. And the coral usually abundance around the equator. And in Indonesia, there are area that is known as the coral triangle, where the diversity of the coral in this area is very high. And coral reef ecosystem, it can provide many ecosystem services, such as it can protect the coastline from storms and erosion. It can also become place for tourism. It can be source of food, medicine, and etc. While for the seagrass ecosystems, it's primarily consists of seagrass. So it is a plant that adapted to live a completely submerged life in the marine waters. And they usually often conflated with seaweed, which is a type of algae, but seagrass are true plants. So they have root systems that extend into the ground to take up the nutrients. They also have flowers and also produce seeds. And seagrass also can form dense underwater meadows that covering large areas of the shallow waters. And seagrass also can be found along the coastline in all continents, from the tropical to temperate region, except for the polar region. And seagrass ecosystem provide many ecosystem services, such as it become a nursery and habitat for many marine organisms, and also important food source for many marine species, such as sea urchins, dugongs, and sea turtles. And they also contribute to the physical, chemicals, and biological structure of the coastal environment. And they also can be biological indicators for of the water quality and ecosystem health. However, recently, there are global threats to the coastal ecosystem. So as we know that the CO2 concentration in the atmosphere is vastly increasing due to the fast fossil fuel combustion. And previously, before the Industrial Revolution, the CO2 concentration is below the 300 ppm. But now the concentration is more than 400 ppm, and it is predicted to be more than 1,000 ppm by the end of the century if we still live using a high fossil fuel life. And these have consequences such as warming the ocean and acidify the ocean. So first, what is the ocean warming? So to lift it up the name, so the oceans is become warmer than before. It is due to the fast increasing of the CO2 at the atmosphere, and it act as greenhouse gases. And when there is incoming solar radiation, the heat inside it's trapped and cannot be emitted back to the outer space. So there is a Earth energy imbalance, or EEI. And with the high emitted infrared radiation or heat, so most of the heat will be absorbed by the ocean, and as a consequences, the ocean become warming. And one of the effect, it can make the marine calcifier such as coral to become bleach. So it is predicted that that in the future, the ocean will warm. It can be up to 5 Celsius degree if we didn't, if we still use the fossil fuel with a high usage. And as for the ocean acidification, so with the fast increasing of the CO2 concentration in the atmosphere, so the CO2 is mostly absorbed by the ocean. So here, the CO2 will react with the seawater to form the carbonic acid. And to balance the reaction, the carbonic acid will form the bicarbonate ion and also the hydrogen ion. And as a result, also to balance again the reaction, the hydrogen ion will react with the carbonate ion to form another bicarbonate ion and hydrogen ion and so on. And as we know that in chemistry, that high concentration of the hydrogen ion, it will be more acidic. So in the past, the pH of the seawater is about 8.2, but due to the acidification, it's already 8.1, and it's predicted that it can reach to be less than 7.8 by the end of this century. And has a consequences because the carbonate ion that react with the hydrogen, it's also came from the calcium carbonate. So there will be a decrease in carbonate saturation state. So as I mentioned before, that the pH of the seawater, it can decrease to below 7.8 by the end of this century. So what is the consequences? So if there is a decrease in aragonate saturation state, it will decrease the calcification rate of many marine calcifiers. For example, here, the net calcification, the net community calcification rate is decreased with the decreasing of the aragonate saturation state. And if the aragonate saturation is reached about 1, it can lead to the net dissolution rather than the net calcification of the calcifiers, and it make bioerosion. And the effects of ocean warming and acidification on some coastal organisms, for example, as mentioned before, it can lead to the coral bleaching, weaken coral skeleton, and reduce their growth rate. And for other calcifier, it can increase the grazing, it can reduce the growth rate and decrease the test thickness, and also damage their feeding parts. And for other organisms, such as the macrophyte, here in this example, the seaweeds and seagrass, their photosynthesis and growth rate is rather be increased, so they are positively affected by the warming and acidification. However, most of the study only focus on the single organisms, and the study on the effect of warming and acidification on organism interactions are still limited. So why study about the interaction is important? Because interactions are the core of ecology. So organisms, they are interact with each other and also with the environment. And by studying the interaction also, it can help us to understand the many fundamental ecological theories. Like, for example, here, the schematic illustration about the core process on coral reefs and their linkage. So the process, the ecosystem function in coral reefs, here mediated by the environmental drivers and the intrinsic drivers that influenced by the species presence on coral reef itself. And here, by studying the interaction, it will help us to simplify the highly complex structure of ecological communities. And in this study, I divided the interaction into two parts, the non-trophic and the trophic interactions. So for the non-trophic interactions, is usually correlated with the habitat modification or stress amelioration by the organisms. Like here, for example, the seagrass, it can bind the sediments, so it makes the water become clearer for the coral reefs. And as mentioned about the stress amelioration, marine macrophytes such as seaweed and seagrass also suggests that they can ameliorate the effect of ocean acidification and provide habitat refugia for calcifiers such as corals, because they can uptake the CO2 via their photosynthesis and then increase the seawater pH of their surrounding environments. So the seaweed farms here suggested to become OA mitigation because it can raise the seawater pH, it can sequester the carbon, and also they provide food production with reduced CO2 footprint, and also provide refugia by here, for example, increase mussel calcification. However, the increasing of pH in seaweed farms is still not known that whether it can be a habitat refugia for corals. And for the trophic interactions, it's correlated when one organism feeds on another. For example, this is the classic top-down control between kelp forest, sea urchin, and sea otter. And here, usually the kelp is eaten by the sea urchin and sea urchin is eaten by the sea otter. But when the sea otter is not present, so there is a strong grazing effect by the sea urchin. And it's also happen in the seagrass ecosystem. For example, here the sea urchin Amblypneutus pallidus in seagrass Amphibolis antarctica. So with the presence of this sea urchin, there is bare seagrass beds. So sea urchin here can play a pivotal role in controlling the abundance of seagrass via their grazing. And ocean warming and acidification is potentially modify the trophic interaction because it can modify the CN ratio, so it will affect the nutritional quality of the seagrass, and it will affect the feeding rate of the sea urchin. So the research gaps in this study, because no study yet assessed the seaweed habitat as a refugia for coral. So here I conducted the seaweed and coral study interaction, and the second, the seagrass sea urchin trophic interaction under warming and acidification is not well understood. Here I study for the second study. So for the first study, I'm doing the laboratory experiment. I'm sampling the coral Montipora digitata from BC. So it's a shallow reef lagoon. And it's sometimes found near the seaweed cultivating site. And seaweed mozuku is one of the well-known seaweed in Okinawa. And major mozuku production in Japan is came from Okinawa. And in this study, I'm using two different PCO2, the control and under OA condition. So we can see from this graph that with the seaweed presence, there is a large diurnal variation in the aquarium. And so they can create bigger pH fluctuation compared to the non-seaweed. And also it results with the bigger aragonite fluctuation in the aquarium. And then in this study, it shows that there was no significant difference in net photosynthetic of the seaweed between control and OA. So suggested that the photosynthesis of seaweed Nemacystus decipiens was not affected by OA. And by conducting the pH drift measurement. This is to measure the bicarbonate utilization by seaweed. So the seaweed Nemacystus, they can increase the seawater to more than 9 in both control and OA condition. So it means that the CO2 is not limiting factor for their photosynthesis because above pH 9, the CO2 concentration is almost 0. So it suggests that this species can use bicarbonate as a carbon source for photosynthesis, and they may possess CO2 concentrating mechanisms that allow them to utilize bicarbonate to provide CO2 during the photosynthesis. That's why they have a less response to CO2 increase. However, contrary to our hypothesis that seaweed can provide habitat refugia for coral, in this study show that there is a decrease in the coral calcification to be about 37% compared to control. And here, the seaweed presence intensifies the effect of ocean acidification and further decrease the coral net calcification rather than ameliorate the effect of OA. And the negative effect of nighttime pH, it might be outweigh the positive effect of daytime pH by the seaweed. Here in this study, the nighttime pH is about 7.75 with aragonate saturation state about 1.32. So it's close to undersaturated condition and suggested there is a decrease in the dark calcification of the coral that leads to the coral dissolution. However, these species have a potential to sequester CO2. So if we expand to the total seaweed mozuku farms in Okinawa, so this species is estimated, this species with Okinawa mozuku is estimated can potentially assimilate CO2 around 60 mega 60 ton carbon per year. And so although seaweed mozuku was found to not act as a habitat refugia for coral against OA, but it still can mitigate the OA effect to the seawater. And for the seagrass and sea urchin interaction for the trophic interaction. Here I'm using a seagrass Thalassia hemprichi that is the most commonly found seagrass in Indo-Pacific region, and also the sea urchin Trypneustus gratilla that usually live within the seagrass Thalassia hemprichi beds, and it's primarily leaving the leaves of the seagrass Thalassia hemprichi. And in this study, I'm using treatment a combination of acidification and warming. So for the seagrass net photosynthesis, it shows that in both acidification condition, in independent and combined effect with warming, there is an increase in seagrass net photosynthesis. And based on previous study, seagrass can use CO2 for photosynthesis. So that's why they have a positive effect on acidification. And also known that they less saturated under the current CO2 level. So here, due to the high seagrass productivity under the OA condition, there will be increase in blue carbon effectiveness by the seagrass, and it will strengthen the bottom-up control by the seagrass. While for the sea urchin feeding rate, there is a slowdown or the decrease in the grazing pressure by the sea urchin, particularly by the warming, and it can weaken the top-down control by the sea urchin. So it potentially have a cascading effect to the entire ecosystems. So to conclude, the interaction of warming and acidification with one species or between species, it can alter the sensitivity of other organisms to climate change. And here, warming and acidification potentially shift the equilibrium that regulating the reef ecosystem, that including coral reefs and seagrass beds, and it can leading to change in ecosystem functions and services. And by understanding the organism interactions is important for adaptive strategies to mitigate the impacts of warming and acidification on reef ecosystems. And I would like to say thanks for the Professor Haruko Kurihara and also the other Lab Kurihara members, and also for the supporting scholarship during my PhD study. So this is the end of my presentation. Thank you for your kind attention.
Thank you, Vina. It's a very interesting materials for us. Ladies and gentlemen, we begin the Q&A session. In the chat room, there are 3 or 4 questions. I will read for you. First question is for Dr. Simon from Erma Musbita Tiastuti. Dr. Simon, I think the problem we're facing on integrating nature and text is relatively similar, but I believe we tried our best to overcome it. Earlier, we've watched and enjoyed the video of student interacted with monkeys, macaca. Actually, it's an assignment to our student for their excursion project. We've instructed the student to observe the natural behaviors of macaca in their habitat and ask the student to present the result in form of video. What do you think about that, Simon?
Thank you, and thank you for the question, Terima kasih. In Australia, we do similar things where we incorporate technology and filming using iPads and cameras. I think it is a really great start, and I definitely think it is part of the solution. I enjoy these approaches because they give the technology a focus and a purpose. Often technology, in my experience, and in my research, has become a bit of a quick fix solution for students who may be experiencing poor behaviors, who may be challenging, maybe even some kind of distraction tool or time filling tool. I really enjoyed observing your students on their excursion and using the technology very purposefully. I think we can enhance this practice though, and it depends how it's introduced. I have seen students go and take their photo. I'll just use my tool here. So they'll go out and they'll just be looking through the lens the whole time, and they won't engage with the natural environment. So I think the practice that we've been trialing in Australia is about connecting with place first. And to do that, we also encourage a connection with our bodies and how our bodies feel first, and then taking a moment to connect with place. And that bit can be through observation of what people are noticing and how it might feel different to being inside. And also taking a moment to appreciate the natural environment while we're outside. What is it that we notice and what we connect to and what we really then value? Because if we don't have value for the natural environment, that's when it's in trouble, if we're not looking after it and valuing it. So my suggestion is to make it more of a sensory experience where students are taking time away from the technology while they're there to see what they observe, away from the focus, and then introducing the technology, such as the camera, as a tool to support them to do what they need to do in their assignments or in what they're doing out there. Thank you.
So we can consider that it's a part of a solution to anticipate the disruption technology to disrupt our children. Maybe that's our environment is one of solution, right?
Yes, exactly.
Okay,
Yeah.
thank you. Thank you, Erma, for your question. And then the next question, for Simon. This is from Abu Habib Maulana Shahid. What a wonderful presentation, Dr. Simon, and I love the way you said terima kasih. Can you try say terima kasih to all of us, Simon?
Certainly. Terima kasih.
Oh, yes, thank you. Appreciate that. My question is, how do you think about integrations of science education that promotes sustainability and environmental awareness when on the contrary, children and many educators now are more inclined towards gadgets and screen-based activity rather than nature? What is your opinion? I think your opinions is, you said, maybe to answer Abu Habib Maulana, please answer the question. Thank you, Simon.
Thank you so much. Thank you very much. I appreciate it. And a great question. In my practice, I really promote taking children outside. And I do it in a way where children have boundaries, because a lot of the research suggests that teachers are afraid to take children outside because they don't have the four walls of the classroom, and children, they think, don't have boundaries and will run wild and they won't have control. But I encourage teachers to take children outside more regularly so they become used to having their children outside, and do it with boundaries as well as having a purpose to going outside. And the purpose may even just be to connect with nature. So in my science education classes that I run with the pre-service teachers, I take them outside as often as I can across all the different areas of science. We'll go outside for physics, for biology, for chemistry, and for earth and environmental science as well. And I show the pre-service teachers, the university students who are going to be teachers, how they can incorporate the environment and nature into their practice as a teacher. And I also talk about using digital technology wisely and in a way that's going to upskill them in their professions and for their future, and not as a tool for distraction or to fill in time. And I encourage teachers to be scientists, to be pedagogical scientists, and observe the impact of digital technology on children and how their behaviours may change, how it may influence them. And I've been doing this for about a decade in my practice, and it's interesting for me, I observe children thrive when they are outside. I see them empowered, and I see them make intelligent decisions about their bodies and for themselves. Often when I observe them on screens for a long time, then I see their bodies change, they slump, they seem less vital, and they seem disconnected from themselves. And so that's also been supported by some of the emergent research that I've been reading as well. So even though we can't change every teacher and what every teacher is doing, that is the practice that I promote, because obviously we've only got one planet, one natural environment, and I do as much as I can in my practice to role model how we can keep our children connected to nature for the future. Thank you.
Okay, Thank you for your answer, Simon. We have many challenges to educate our children, right, Simon, for a while, because there are so many technology disrupting to our children nowadays. Thank you. For the next question to Vina. Here in Indonesia, the construction of beach clubs along the coastal is almost in all regions, barely unstoppable. Will it also worsen in the coastal condition? Maybe it will disturb the population of community of the coastal.
So, yeah, we know that in Indonesia, there are so many construction and development in the coastal region. So if it not planned, yes, it will worsen the coastal condition. Like one of the good examples in the northern part of the Java island, around, I forget, around 80s or 90s, they cut most of the mangroves around that area to make, what is it, they culture the shrimps. But they don't know that there will be the next ecological consequences because there are no plants that can bind the sediments. And now we know that in the northern part of Java, there is abrasion. So there is intrusion of the seawater coming to the land. And yeah, based on my family experience, the village that my mother was born is already in the middle of the Java Sea right now. So it's a quite fast abrasion. But if we plant the the development using the integrated management. So we really planned doing the environmental assessment and incorporate, for example, the environment, the culture, and economically sustainable. So we might have more sustainable coastal area. But if it's unplanned and just based on the economy, so yeah, it will worsen the coastal condition.
Okay, thank you, Vina, for your answer. For student UMS, is there any question for the three speakers? Great speakers here. Do you have any question? One more from Jumadi, from Pak Jumadi. To Dr. To Vina, ya. Please explain the difference between seagrass and seaweed because seagrass sounds unfamiliar to me. Thank you. Thank you, Vina.
Yeah, so basically seaweed and seagrass is a different plants. It's a different group. So the seaweed, as we know, they don't have the true roots, stems, or leaves, but the seagrass is a angiosperm. So they are a flowering plants. They have plants, they have flower, they have seeds, they have roots. They can go to the ground and take up the nutrients. So basically, it's just like plants that living underwater. And in Indonesia, I don't know why they translated to lamun. So I don't know what's the meaning lamun in Indonesian actually, because we just if we translated the seagrass to Indonesian is a bit constricted with the seaweed translation. But the seagrass are true plants and seaweed are not. So yeah, that's the difference.
Okay. That's the question from Paramita, to Simon, how do you assess their activity and make a comprehensive result? What is the most significant change when you try to elaborate this new curriculum? In Indonesia, we have a curriculum merdeka. Yes, maybe you familiar or not with curriculum merdeka or not familiar with curriculum merdeka. Maybe we all have a different curriculum, Australia and Indonesia, right? Both of them are more flexible for the teacher to reconstruct, but I found several difficulties, especially when I want to make a comprehensive assessment and make sure that I have made meaningful learning with my student. Maybe the main question is, how do you assess their activity and make a comprehensive result from teaching and learning in Australia, maybe?
And I might need to clarify, is that about sustainability, about the knowledge of sustainability and the environment?
Pardon?
Because is it about how do you assess their activity of sustainability and the environment to make a comprehensive result?
Oh,
is that
maybe Paramita will ask you directly.
Yeah, certainly.
Paramita, are you here? Simon, maybe
Yes, I do
Paramita will
understand.
ask you directly about the question.
Thank you very much. Thank you, moderator.
Please.
Paramita. Hello.
Hello, Simon.
Hello. Thank you for your
I
question.
mean, when you try to teach about sustainability to your students, how you assess or how you know that your students can accept your learning? How you assess them? In I say about in Indonesia we have a curriculum merdeka or independence curriculum, which is teacher have more flexibility to reconstruct their education, their learning, but some of them, or maybe I am personally find a difficulties when I need to assess full assessment to my students. Maybe I mean, how I know that my students fully accepted my learning. Maybe you have some
Yeah.
tips for me or for us.
Yeah, certainly. So in Australia, we do a lot of formative assessment. Do you know formative assessment? Is that you
Okay.
use that in? So we're taking a lot of assessment all of the time. It's not summative assessment, which we take at the end of a unit of work, but we take a lot of assessments along the way. It could be as simple as having class discussions or asking students questions, and we take note of where the student learning is at. We're always doing this practice. It's very consistent. And so we know how to change the learning to support the students along the way. The summative assessment, which is the assessment at the end of a unit, which we use to inform our reporting, is generally more formal. And we have a lot of forms. So I know traditionally there's exams, but we do exams, but we also like to do a lot of different things for our students. I noticed one of your colleagues used the video for an assessment. We do things like that as well. So students might make a video, or they might make like a photo strip of different scenarios, and we use our marking rubrics. We use a lot of marking rubrics in Australia to assess student work. And within that, we can map the science outcomes alongside our sustainability measures or goals, which I showed as the sustainability organizing ideas. So we can embed that within our science education. But we use a lot of creative approaches, not just reports and exams and tests all the time, because we found that that doesn't support student engagement in science. They don't often enjoy it, especially if they don't want to continue with science later on. So we try and look at ways that students can do other things, sometimes making a model or doing annotated drawings. What else do we do? Sometimes it can even be games that we make up. So they have a game as an assessment. They might make a game, or the teacher might set a game that the students are involved with, which is assessed. And there's different ways to document things like that, whether it's anecdotal notes or whether it's video recordings these days as well that teachers will keep for their records. Does that assist, Aramiva? Yeah.
Okay, thank you, Simon, for your answer.
Thank you so much. It was a great question, and I think assessment is something we have to talk about a lot. So thank you. Thank you.
Maybe the next question is to Prof. Nazia about genetics. Is from Yasir Siddiq.
Thank you, Every, for the opportunity, and thank you to all speakers today. And my question will be designated to the Professor Nazia Jamil, since it related to my current study. Thank you, Prof. Nazia. And I'm imagining the huge effort and collaboration to reach your goals in the experiment to produce biofilm from bacteria. And you already explained from the isolation from the environment to the mass production, I think, and also many collaborators. And there are 3 questions from me and from my colleagues in here. And the first question is, among 3 kinds of PHA, that you explained earlier, could we say which one of them is the most accumulated in the bacteria? And which one of these 3 PHA that you use for the current experiment? All of the 3 kind of PHA, or 2 of them, or 1 of them? And the second question, this is from my college, my friends, Bu Triastuti Rahayu. And why did Prof. Nazia select PHA producing bacteria from sludge? Can we, as you mentioned earlier, there are many environments that potentially we can isolate the PHA producing bacteria, but is there any environment sources such as cemeteries, maybe, and other environment sources? And the last question is, based on your experience, do lipolytic bacteria have the potential to produce PHA? The lipolytic bacteria, Prof, is it also potential to produce PHA? Or based on your experience, is it potential or not? And here we have a collection of Bacillus aryabhatatai from the cemetery soils. And based on Prof. Nazia's research, it was detected to have PHA operon. Is it potential or unpotential, Prof? Thank you. That's all 3 questions.
Regarding the 3 types, usually the bacteria which grow on the glucose using as a substrate, they are producing the brittle PHA, that is the PHB. And if we, but some bacteria also convert these monomers of the glucose to the medium chain as well. But this is all depends that what's its genetics is, how they are metabolizing that substrate. Mostly we find the brittle one, that is the PHB. It is also in the first stage, they are appears all bacteria appears the accumulation granules and show the fluorescence under the microscope, oil emulsions and all that. But after the extraction and structural elucidations, we find out clear cut distinction between the brittle one and the other one. But usually the storage granules, they are the brittle one, that is the PHB. But the medium chain are very, very good. Their properties are very much similar. You can find the literature everywhere about these medium chain PHs. They are about to be the 5 to 6 or 8 carbon long chain. They from, especially from the oil or long, if we are providing them the long chain, straight away equation is the providing the long chain, they will produce the long chain or the medium chain carbon sources. But over here their metabolism is included very much. Their genetics is over there, because sometimes we are just providing the glucose monomers and they are producing the medium chain. This is also we find out. And regarding the symmetry, that organisms, yes, we can, the basic tests, if you people perform and find out, that is with the Nile blue and the Sudan black staining. That is very easy processes. Screen them out first and then go for the different extraction methods. We did a lot extractions or solvent based, but nowadays due to environmental issues, we prefer a non-solvent one. But the results are very, very good with the solvent one. And if the that polymer is incubated for longer times, it starts degradation. So the time calculations and all that stuff is variable with the bacteria as well. So it all depends that yes, mostly mostly the bacteria has the PHA granules in them for their storage, because they are energy storage granules. But we exploit after the extraction, we use as a bioplastic. But when the nutrition depletion conditions finish and they start using again that polymer as for their energy source. So the same bacteria which is producing after the time period that specific time finishes, it start using that and producing no polymer over there. So it all the calculations over there over the time, and very carefully screening processes, very careful about the sampling sites. I'm very with your study that is about the symmetry that in the data brief. And yes, we should go for that one. It is very has a potential for that. I think they will produce over there on they in the first stage they will show positively. The bacillus has also positive for that one, but sometimes people mistakenly mix it with the, when they under the oil emulsions in the light microscope, they mix with the bacillus as a spore former as well. So they mix those spores with the PHA spores. So at that time you should be very clear. But the Nile blue in the plates giving the fluorescence is also very good test. Hopefully I answer all three, or is there any other question rest?
Yeah, I think all questions are answered, but one question didn't answer is why did you select bacteria from sludge? Is it any certain reason for that?
Sorry, why
From
we use
from sludge?
from sludge?
Yeah.
Yes, actually, those people that is from this project, actually from the Brisbane treatment plant. The scientists over there, they are working on the sludge. They are not doing any isolation and purification thing. My student went over there with their with her bacterial strains isolated from here Pakistan and bring it over there. But over there, what they are doing, they are taking the sludge, centrifuging that and treating that. They are isolating the, because in the sludge there is a different type of the carbon sources over there, and the different bacteria is there, and they are using that bacteria, using that substrates and using those substrates and accumulating. So they are directly isolating from the mixed open sort of thing, the plastic films. So they are working on that one. And we are using the wastewater as a carbon source without sterilization.
Okay.
Without just we did the preliminary treatment, that is the either the centrifugation or the filtration, not the sterilization to reduce the process optimization cost.
Okay. Thank you, Prof. Nazia. But I want to answer one thing that about the method of to ensure the PHA producing bacteria. First, we should do the black staining, right? And
Sudan
then
black staining,
Sudan black staining, and then isolate the PHA, and then do the genetic assessment.
Yes, there are also one of the, nowadays we also doing some subtype of this work, this whole genome metagenome projects. What in that one, directly take the sample, go for the whole genome metagenome and find out that is there bacteria, which type of bacteria is there, and they are producing PHA genes or not, and directly target them out.
Okay,
These
is it
are
also
many,
possible, right?
yes, this is also possible. So
Okay.
there are many different things. Or either you can directly take the sample and spread it on a Nile blue Petri plates, supplemented, that is the PDA media, supplemented with Nile blue, and directly spread the sample. And if the fluorescence is over there, you can find out that yes, these bacteria has the fluorescence. Just expose 1 or 2 few seconds, expose them, find out the bacteria, and pick them out. This is
Okay.
also one of the shortcut.
Okay.
So
Thank
there
you
are
very much,
many.
Prof. Nazia.
Thank you. Thank you.
Thank you very much, Prof. Nazia. A very amazing answer from Professor Nazia to Yasir Siddiq.
Thank you. Thank you.
Well, everybody, this is the end of our meeting, and we have heard and understanding about the materials from 3 great speakers. Before we closing our session, give big applause to our speakers.
Clapping for you people as well. You people did a great job here. Thank you.
Thank you very much.
Okay, thank you, Professor Nazia. Well, everybody, before this session ending, we have finished our meetings for this session. Thank you very much for your attention. Back to Master of Ceremony.
Thank you to the invited speakers for fruitful presentation and discussion. Next, we are present the certificate of appreciation to our invited speakers. First, for Dr. Simon M. Blom, Ph.D.
Thank you very much.
Second,
Very great honor to
Professor
be invited
Nazia
to
Jamil,
present today.
Ph.D.
Thank you.
The last but not least, for Dr. Vina Listiawati, Ph.D. Okay. Ladies and gentlemen, please join me in giving a warm round of applause to our esteemed invited speakers. Thank you, Ms. Dr. Evri Roziati, Magister Science, for bringing us to a very interesting and productive session today. May all the presentation and discussion give us more insights on biological rules to solve the environmental issues. Now, I would like to read some announcement for the participants. Please pay more attention. First, participants are requested to join at the specified Zoom link. Second, for presenters who have not submitted articles and PowerPoint presentations, please collect them immediately at the available link. Third, reminder to fill in attendance. Fourth, reminder to submit proof of registration. Fifth, reminder to upload presentation file. Sixth, prepare the full paper to be uploaded during the parallel session attendance. The last, prepare to join the parallel session according to the schedule and room Zoom available in the Incobest 2024 abstract ebook. Alhamdulillahirabbil alamin. Thanks to Allah, we finally finished all the agenda for today. On the behalf of the committee, we would like to say thank you for your active participation today. We also ask for your forgiveness for any wrongdoing and have a great rest of your day. See you in the third Incobest next year, inshallah. I am Amalia Febrianti, signing off. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Warahmatullahi wabarakatuh.
Thank you, Dr. Simon. Thank you, Prof. Nazia Jamil. See you in the next opportunity. See you.